Zoom recording. Okay, there we go. All right, so we now have, so other than those anions, other than the two strong bases, and who are the two strong bases? Two strong Bronsted-Lowry bases. Keep going all the way to the bottom of your data booklet, because your two strong bases are, is it OH and NH3, or is it O2 minus and NH2? Which of those are, let's call this option A, let's call this option B. Who are the strong bases? Yes, option B. Okay, these guys are just too weak to act as acids. Okay, they're not actually, they are conjugate acids, but they are too weak to act as acids. Okay, excellent. So back to here. So other than our two strong bases, which are NH2 minus and O2, they are in the gray section at the bottom of the table. And those conjugate bases of strong acids, those ones up here, which are also in a gray area. All the rest of the anions are weak bases, or at least they're amphiprotic or amphiprotic. In other words, those that are in the white section of the data table. So I tried to put some of it on here. I just put in a section of it, but obviously there's a whole lot more in between. It just wouldn't all fit on the page. Okay, you will not be given the KB. Now, if you remember all of these things, they all have KAs. Okay, so if we look at our data table here, you know, here is a weak base, CN minus, and its conjugate acid has a Ka value, but there is no list of Kb values here. However, I'm not going to give you a Kb for Cn minus if you need to work with it. I'm going to expect you to be able to find it, because there is a simple relationship between Ka of an acid and Kb of the conjugate base. So what is that simple mathematical relationship? If you want to find Kb of an anion or any other base, you will take Kw and divide by Ka of its conjugate acid. And a more generic way of writing this is simply that Kw is equal to Ka times Kb. I am going to skip over the where does this formula come from. I will come back to it at the end. So if you're interested, you can hang around for that. And if not, we won't worry about it. But what we're going to do, we're going to focus here. Okay. So this formula works not only for anions, but also for molecular uncharged bases like ammonia and other amines. Okay, so for ammonia, the Kb of NH3 is going to equal our Kw divided by the Ka of the conjugate acid. And what I want to do is I want to put here the formula of the conjugate acid. What is the formula of the conjugate acid of NH3? Yeah, NH4. Okay, so we're going to put NH4 plus. And I'm going to recommend that when you start out, write out this entire thing, or you abbreviate conjugate conjugate by just conj, okay? And you'll see why in a few minutes. All right, so let's do a calculation. Let us calculate the Kb for F minus. So first of all, we have to prove to ourselves that F minus can act as a base, because if I gave you a different ion, maybe it couldn't act as a base. So let's write our products here. The hydrogen is going to go from water onto fluoride, and so we will end up with HF, and we had a minus. When it gets together with the plus, now it becomes neutral. And we are left with water has lost a proton, so it becomes OH minus. Okay, now we look at this acid here, and we say to ourselves, is HF strong or weak? And we go to our data booklet, and we say, HF, where are you? HF, you are in the weak section. You're in that white section there. Okay, so we're going to go back to here. And so it is a weak acid, and therefore F minus is able to act as a base. Let's say I had X minus plus H2O, and it gave me HX plus OH minus. Let's say that that was a strong acid. Then what should we do with that equation? We should say no. Okay, if this is a strong acid, then this guy, remember, is too weak to be a base, and therefore it would have no Kb. If the conjugate acid is strong, then that conjugate base is too weak to be a base, and it has no Kb. But we have a base which is weak, or sorry, we have a base which is weak, but also its conjugate acid is weak. So it's not strong, it is weak. So we are going to write the Kb for F minus. And what goes on the top of this equation, if we want to find it? What goes on the top of this equation? Kw over Ka. And do I just write Ka, or do I write something more? Of the conjugate acid. And in fact, I'm going to stick the conjugate acid in right there, and that is HF. And then we just go to our, man, I've written big and everywhere. I've not left myself much room. That's okay, I can cram it in down here. I've got my Kw 1.0 times 10 to the negative 14 divided by, and I threw this in here so I didn't have to go looking for it, 3.5 times 10 to the negative 4. And I did not print out my cheat sheet ahead of time, so let me just throw this in the calculator real quick. Divided by 3.5 times 10 to the minus 4, and we get 2.9 times 10 to the negative 11 is the Kb for F minus. That's all. Did you like that? Was that easy? Hope so. Now, it may be a pain in the butt to always write out this whole thing rather than just this bit here. Okay, that would be nice, wouldn't it? And eventually you might get to the point where you can do that, but I'm going to recommend that you don't do it to start with, because here is why. We're going to try and avoid the most common mistake people make when they are trying to find Kb. And it happens when you have amphiprotic substances. Okay, so let's take a look here. We have, let's find the Kb of HCO3. Well, Kw, yay. I know that's 1 times 10 to the negative 14, so that's great. Now, HCO3, oh, I looked that up here. Here it is. And I look over here. Hang on, come on. Yeah, you got cut off there. Okay. And I look up and I say, oh, look, my Ka is 5.6 times 10 to the negative 11. And do the division, and I get 1.8 times 10 to the minus 4. And don't you know it, this is a multiple choice question, and that is one of the answers. And that is wrong. What have I done wrong? HCO3 is not the conjugate acid. Yes, okay. HCO3 is not conjugate acid. So this is the Ka of HCO3, not H2CO3. And we have to always have that second hydrogen, or third hydrogen sometimes, on the bottom there. Okay, so I don't know. I've already written what was wrong with it up there. Not conjugate acid. There we go. Okay, so now let's do it correctly. Look, I am looking for my Kb. So when finding Kb, I'm going to look for HCO3 on the base side. Yes. And so I'm going to have Kb is equal to Kw over, actually, I should be writing in Kb of HCO3 minus Kb, and for now I'm going to write out the conjugate acid, and I'm going to write H. Make sure you add a second H, okay, to CO3, and then we have, that's just 1 times 1.0 times 10 to the negative 14 over, and we've got our new value here, 4.3 times 10 to the negative 7, that is for the H2CO3, and we get ooh, here's a handy tip. If you are doing a lot of these calculations all at once, you might want to plug into your calculator into like the memory function, 1 times 10 to the negative 14. Save some typing, okay? At any rate, to avoid any mistakes, you're always going to write Kb of whatever is equal to Kw over Ka of the conjugate acid, and you're going to add that extra hydrogen there. Okay, fill in the formulas. If you get to the point where you're like, I don't want to write this part anymore of the conjugate acid, you can certainly just write in your base and then your acid, and that would work just fine. Okay, as a reminder to you of what you need to do. All right, my friends, let's calculate the Kb for Br minus. Let's see if Br can act as a base. HBr plus H2O. And what you should always do at this point is you should always check, is this strong or weak? Okay, this is going to come in handy for hydrolysis next week. So always be checking, is your product strong or weak? If your product is strong, can you form it? Can you form a strong product? No, no, you can't. Okay. If these guys are strong, they are like HBr is pushing the reaction all the way that way, so it doesn't go that way. So Br minus is not able to act as a base, and therefore it does not have a KB. And guess what? I promised this would be a short one today. We are done. The worksheet itself is like 7 questions, 8 questions. It's pretty straightforward. And just to remind people, if you came into the meeting a little bit late, we talked about what you should be doing this weekend. You should be number 1. If you have a missing quiz or test, contact me to set up a time and study. Okay. You should be doing 5.2b, which is really short. You should be doing some of, I would suggest, the odd questions, the acid base 1 review if you have not already done so. And number 4 is optional, but it will help you out during Monday's lesson. Read Hebden pages 144 to 147. Okie dokie. Does anybody have any questions about anything? All right. Just give me 1 second here. There we go. That's it. Okay, awesome. Thank you guys so much. I'm just checking out who's actually here, just so that I have a general idea who's going to have to get caught up on stuff. But it's looking like so many of you are here. That's wonderful. Thank you so much. I know you didn't have to do this. You must care about your education. Have a wonderful weekend, and I will see you in person next week.